Hello, girls. I hope you've had a great day and you are really excited to start a new section in AP Maths. This section is rational inequalities. It's actually not completely new to you. You've done it in core, but you've been restricted to quadratic inequalities or parabolas, basically. So in this lesson, we're going to look at examples that are not parabolas. So you don't have an idea what the graph should look like, or even have to be able to sketch it. But let's look at this example one. So you can see that first of all, it is fully factorized and we have it equal to 0 on the right hand side. So we need to make it equal to 0 and we need to fully factorize. So in other words, here there's nothing that we can do other than go straight to the number line. Right, so the critical values in this case are x equals 2, x equals -3, and x equals 1. Right, those are the three values at which signs will change. So we start with the smallest one, -3, then we go to 1, and then we go to 2. Right. So I like to start with a value between -3 and 1 because I can use 0 to start with, which is always easier. Right, so if I use 0, let's use red. If I use 0 and I substitute x equals 0, then in the first bracket over here, I'm going to have 2 minus 0, which is 2. That's a positive answer. And then I'm going to have in the next bracket 0 plus 3, which is a positive answer. And then I'm going to have 0 minus 1, which was -1, which is a negative answer. So I'm going to have a negative between those two values. Now if I try, let's use yellow, a value between 1 and 2, then we're going to say, let's say 1.5. So 2 minus 1.5 is a half, which is positive. And then 1.5 plus 3 is 4.5, which is positive. And 1.5 minus 1 is a half, which is also positive. So we get a positive between 1 and 2. All right, I'm not going to test further values, but if you choose something greater than 2, you'll see you'll get a negative. And if you choose something less than -3, you'll get a positive answer. Right, so now we know we're looking for negative, less than or equal solutions. So that means we want that solution and we want that solution. Right, so that means we first have to also check what is allowed and what is not. So it's less than or equal to. Right, so technically all the critical values could possibly be allowed. -3 is allowed. A positive 2 is allowed. But positive 1 is not allowed because remember, that will make the denominator undefined. Right, so our solutions then are -3, which is less than or equal to x, less than 1, not less than or equal to, or x is greater than or equal to 2. Okay, so that accounts for those solutions and these solutions to positive infinity. Right, example 2, 3 over x is greater than or equal to x over 3. Now the temptation here might be to find an LCD, multiply by the LCD to both sides to get rid of the denominators. But the problem here is when you multiply an inequality by a negative, you have to change the direction of the inequality sign. Now, we don't know with a variable whether it's negative or not. So in other words, we don't know whether to change the direction of the sign or not. So the best method here is to rather bring the x over 3 over. So we have 3 over x minus x over 3 is greater than or equal to 0. Right, now we find an LCD on the left-hand side. So that would be 3x. And we'd have 9 minus x squared on the left-hand side in the numerator. So now we can factorize that numerator to give us 3 minus x and 3 plus x over 3x is greater than or equal to 0. Right, so we have critical values now of x equals plus minus 3 and x equals 0 for the denominator. Right, so our number line looks like this. -3, 0, and +3. Now, if we choose a value in between each of those, let's say I'm going to first look at a value between 0 and 3, which I'm going to choose 1. So if x is 1, substitute it into these three brackets and see what you get. So if x is 1, then 3 minus 1 is 2, which is positive. 3 plus 1 is 4, which is positive. And 3 times 1 in the denominator is 3, which is positive. So we clearly get a positive value there. Let's try in yellow a number greater than 3. So let's say 5. So in the first bracket, 3 minus 5 is -2, so that's negative. In the second bracket, 3 plus 5 is 8, which is positive. And in the denominator, 3 times 5 is 15, which is positive. So that gives us a negative then. A negative times a positive times a positive. And you can test the rest of them, but for now they will alternate. So this will be negative and that will be positive. They won't always alternate. There will be an exception in an example to come, which I'll show you. But otherwise, they will alternate other than that exception. Right, so if we can go to the solution now, I'll write the solution at the top here. We're looking for greater than, so positive answers, greater than 0. So in other words, we want these solutions and we want those solutions. Right, so the final solution will be x is less than, and we need to look at what is allowed and what's not allowed. So -3 is allowed, +3 is allowed because it won't make it undefined, but x equals 0 is not allowed. So back to our solution, x is less than or equal to -3, or x is between 0 and x and +3 equals. Okay, so 3 is included, but the 0 isn't. Right, example 3. Now in this case, as opposed to the previous example, we can actually multiply by x minus 1 all squared. Because remember, it doesn't matter what x is, that whole bracket in the denominator will always be positive. So we can go straight to saying 4 is greater than or equal to x minus 1 all squared. Multiply both sides. Right, now what I would do is multiply out the binomial squared to get x squared minus 2x plus 1. Now bring the 4 over. So x squared minus 2x, and then 1 minus 4 is minus 3. And then we factorize the trinomial to read x minus 3 and x plus 1. Right, so our critical values then are +3 and -1. Now remember, before we go to the critical values on the number line, remember that from the denominator here, we have a restriction. So x cannot equal 1. Okay, that's important to remember. Okay, so our critical values here are -1 and +3. Okay, so in this case, -1 is allowed because it's greater than or equal to, and it won't make the denominator 0. And +3 is allowed, so we can give that a solid dot. And let's check values in between. So I'm going to go for 0 because I know 0 is between -1 and 3. So if we test 0, then in the first bracket, x minus 3, we have 0 minus 3, we get a negative. And in the second bracket, we get 0 plus 1, which is a positive, which means we have a negative in between the two values. If we chose something greater than 3, I'll use purple. Say 5. 5 minus 3 is 2, so that's a positive for the first bracket. And then 5 plus 1 is 6. That's a positive for the second bracket, and so we have a positive. Okay, the same, I'm not going to test it now, but the same for values less than -1, you'd end up with a positive. Right, so the solution in this case, remember, look at the step where we have it equated to 0. And that is this step here. We're looking for solutions that are less than 0, negative. So therefore, we want these ones between -1 and 3. Okay, both -1 and 3 are included, so therefore negative 1 is less than or equal to x, which is less than or equal to 3. Okay, example 4. Before we even start with this, we need to look at the restriction. So we know already that x cannot equal 1, okay, because that'll make the denominator undefined. But we can cancel, actually, that x minus 1 with one of these to leave it with x minus 1 to the power of 2. Okay, so in other words, our next step then is that we have x minus 1 squared into x minus 6, which is less than or equal to 0. Right, so we only have two critical values. Here we have positive 1 and positive 6. Right, so if we test values now, let's test 0. So if we test 0, which is to the left of 1, then 0 minus 1 is negative 1, but squared becomes positive 1. Then 0 minus 6 is negative 5. Sorry, listen to me. 0 minus 6 is negative 6. So that's a negative, so we end up then with a negative to the left of 1. Right, to the right of 1, let's use yellow. So let's choose a value of 5. So 5 minus 1 is 4. 4 squared is 16, that's positive. Then in the second bracket, 5 minus 6 is negative 1. So we end up with a negative. So we now have two negatives next to each other. Now look how interesting that is. Negative and a negative. The reason why is because the critical value of 1 was in a bracket that was all squared. Okay, so remember that. When you have a bracket all squared in the numerator of a function, you end up having the signs not alternating but repeating on either side of that critical value. Right, using purple, a value to the right of 6, let's say 10. So 10 minus 1 all squared obviously is 9, which is 81, that is positive. And then on the x minus 6 bracket, 10 minus 6 is 4, so that's also positive, so we end up with a positive there. Okay, now what's important to remember before we do the solution is remember that x cannot equal 1. So there must be an open dot there above the x and a closed dot above the 6. Right, and because we're looking for negative solutions, our final answer will be that x is less than or equal to 6, but x cannot equal 1. All right, that way you've discounted that possibility, but accounted for all of these possibilities to negative infinity. Right, for example 5, the numerator is always going to be negative because there are no variables there. So we're only really looking at the denominator, but remembering that there's a negative in the numerator. Right, so firstly, let's go straight to our number line, because there's no factorizing, there's no simplification to do, and obviously the critical value is x equals negative 1. Okay, that will make the denominator 0. Clearly, straight away, that's not allowed, so we show an open dot there. Right, let's look at a value that is greater than negative 1. So let's say 0. So if we substituted 0, we'd get 1 plus 0 in the denominator, which is 1. And then the negative in the numerator would make that a negative. Try something negative. So let's say negative 10. Anything to the left of negative 1. So negative 10 at the bottom will be negative 10, will be 1 plus negative 10, which is the same as negative 10 plus 1, which is negative 9. And the negative 4 divided by the negative 9 is positive. Right, that's it. So now we know that we're looking for answers that are negative. So therefore we are looking for these solutions. Right, so that means that x is greater than negative 1. Not greater than or equal to, because negative 1 would make it undefined. Right, example 6 is a bit of working out to do first. We've got to factorize the numerator. So we get x minus 1 and x plus 1 in the numerator over x squared plus 1 less than or equal to 0. Now, important to look at the denominator. It's never going to be possible that that denominator equals a negative answer. All right, because any negative answer that x is, or negative value that x is, will square to become positive. And any positive answer will obviously square to become positive. But if x is 0, then 0 squared is 0 plus 1 is positive 1. So we can never get a negative in the denominator. Okay, so straight to looking at the numerators, our critical values are negative 1 and positive 1. Right, so if we choose values in between, let's start with 0. We have 0 in the first bracket, 0 minus 1 is negative 1, so that's negative. In the second bracket, 0 plus 1 is positive. So then obviously we have a negative in between negative 1 and 1, because a negative times a positive is negative. Right, then if you choose values higher than 1, I'm not going to test them, you can test them. But if you choose a value 5, for example, you're going to get a positive there. And you choose a value negative 5, that is to the left of negative 1, you're going to get a positive there. All right, let's just check at the restrictions. There are no restrictions in this case. Both our critical values are fine, because it says that it is x squared minus 1 over x squared plus 1 less than or equal to 0. So the equals means that it can include those numbers. And because there's nothing that can make the denominator negative, or sorry, not negative, but undefined, it means there are no restrictions on the x value in the denominator. Right, so our final answer then is we're looking for negative solutions. So negative 1 is less than equal to x, which is less than equal to 1.